Hello everyone, Noel with AWS here. Today we're solving one of the biggest challenges in AI development. How do we get AI agents built with different frameworks to work together? I'm going to show you the agent-to-agent protocol, also referred to as A2A, and demonstrate how it enables seamless communication between agents regardless of their underlying technology or their hosted locations. But first, let's level set and put some definitions around some related architectural components. All right, so every AI agent, regardless of framework, has these core components: an LLM for reasoning, tools for taking actions, prompts that guide behavior, and memory for context. These elements work together to create an autonomous system that can understand, decide, and act. But there's a problem. Every framework implements these differently. And as we discussed in my previous video, MCP standardizes how agents connect to their tools and resources. The agents act as an MCP client, connecting to MCP servers that provide access to the tools, resources, and prompts. This creates a standardized interface between the agents and their capabilities, but MCP only solves half the problem. What about agent-to-agent communication? And this is where the A2A protocol comes in. Agent-to-agent protocol enables agents on different clouds or within the same cloud, built with different frameworks to discover and communicate with each other. Just like HTTP allows any browser to talk to any web server, A2A allows any agent to talk to any other agent. Each agent can still use MCP for its own tools, but they communicate with each other using the A2A protocol. And what are the elements of an A2A agent? So an A2A agent extends the basic agent concept with agent skills that describes what it can do, tasks for managing work, messages for communication, and parts for different content types, be it data, images, etc., and artifacts for sharing the actual completion, the result. And these standardized components ensure that any A2A agent can understand what another agent is capable of and how to interact with it. So let's discuss what it actually takes to implement A2A. For our demonstration, I created two agents, one with AWS Strands Agents SDK and the other with LangGraph. With the Strands Agents SDK, I had to just define the agent and wrap it in the A2A server, and I was done. And with LangGraph, I had to manually create the executor, task management, and event handling along with the protocol implementation. And we'll get into the bit of details on what those elements are shortly. But it's important to note both frameworks produced a fully compliant A2A agent that communicates perfectly. And it's not about which is better, it's really about having choices. Now, let's see a demonstration of this. As I mentioned previously, I built two AI agents, a student agent using LangGraph that asks confused questions, and a teacher agent that uses Strands that provides adaptive explanations. They're completely different frameworks, and I'm simulating the deployment on different clouds by using different TCP ports, but they communicate seamlessly through the A2A protocol. I built a Streamlit app that visualizes this interaction so you can see the protocol in action. After the Streamlit app walkthrough, then we'll perform a quick code walkthrough as well. Okay, let's jump into our demo. This is the Streamlit app that demonstrates the agent-to-agent communication. Let's discover the agents. Now, each agent publishes an agent card. Think of this like a business card for the AI agents. And let's expand the agent cards here. And the student agent says that it asks confused questions. And the teacher agent says that it provides simple explanations for a student's questions. Neither agent knows how the other agent is built. They just know the capabilities defined in the respective agent cards. Now, I'll enter a concept to teach. And for the interest of time, I defined some predefined examples, but this Streamlit app also allows for free-form text. I'll just use the predefined example for now. So I click gravity, And once I click run, what happens is the text gets wrapped in an A2A message format and it's sent to the student from the teacher agent using the standard JSON-RPC protocol. The student uses LangGraph, processes the input, and it generates a confused question. That question in A2A format goes back to the teacher. The teacher using Strands generates an adaptive response. Let's watch this in action. Okay, so these are the JSON messages. This is an A2A communication in action. Notice the same message format for both agents despite different frameworks. And the student's confusion is generated by Claude Haiku, and the teacher's response adapts to the specific confusion. Uh, and the teacher agent is also running the Haiku model. So let's take another quick example. Let's click on fractions and run the actual interaction. So in this case, the teacher is sending the student, and it's not displaying the full message, but it's teaching the concept of fractions to the student. And the student responds with, okay, I'm confused. Here are my question. In the demonstration, it shows, and again, I'm not showing the full output just because of the page view capability, but you can see it here. If the demonstration shows the total parts, does that mean the numerator has to be less than the denominator? And this is the final response from the actual teacher. Again, all this is happening via the A2A protocol. And you see the responses, the agents running different frameworks. So let's do a quick code walkthrough. Let me jump to my IDE. Okay, I'm in my IDE, and this is the teacher agent. And you notice it's written using the Strands agent SDK. And the tool decorator creates the capability that the agent can use. And you see the agent definition. It defines the name and the description that will be used for agent discovery. We're using the Anthropic Claude Haiku model hosted on Amazon Bedrock. You see our system prompt definition defining the teacher's personality and the tools it can use. And what you see on line 18 here is the A2A server class that takes in our agent's predefined port. And this is what makes the agent A2A compliant. Strands handles all of the protocol details internally. Now, let's look at the agent card via the predefined URL. I actually already have that agent running and the agent card open in my browser. And you see the agent card here for the actual teacher agent. And here's the agent card for the actual student agent. So this is what's published via the URL. And if you deployed this on Bedrock Agent Core, you'd essentially be looking at their endpoint URLs. But we're just using the local host for testing purposes. It's important to note that for local testing, you can invoke these agents via a curl command as well. Now, let's go back to our IDE and let's look at our student agent. Okay, so you see the LLM definition, you see the actual graph state defined, and you see the actual LangGraph graph defined. But then you see an actual agent executor. So I actually wrap the graph with agent executor. And agent executor is what we use to handle incoming messages and manage the task lifecycle and format the responses to artifacts. And artifacts is essentially the completion. Then we define the agent card. And this tells the other agents what this agent can do. Every field that you see for the agent card is required here. And the Starlit wrapper is our web server wrapper. So it's important to know for both agents, with about 3 additional lines of code, I can deploy them to Agent Core's runtime environment. And if you want to know more about Agent Core runtime, I recorded a previous video for that. You can find that on my YouTube. So thus they'll run on secure containers within the AWS cloud. And it's important to note that AWS Strands is an open source framework that's not just limited to running on AWS's cloud as well. So that concludes our demo. I hope you enjoyed and happy building. Take care.